Hey you guys, this is Mr. Millings, and in this video we are going to learn how to calculate the kinetic energy of different objects using the kinetic energy equation that we see right here. Kinetic energy equals 1/2 times the mass times the velocity squared. So what is kinetic energy? Well, in an earlier video, we went into greater detail when we talked about kinetic energy. And kinetic energy is the energy of motion, essentially, and anything that is moving or anything that is in motion has kinetic energy. And we can calculate how much kinetic energy an object has by using this formula right here. Kinetic energy equals 1/2 the mass times the velocity squared, where kinetic energy here is measured in something called the joule, or capital J. Mass right here is measured in something called kilograms, or kg. And the velocity of the object is measured in meters per second. So once we have these known quantities expressed in these units, we can plug them into this kinetic energy equation and solve. So let's go ahead and apply this equation to three different example problems, one in which we solve for kinetic energy, one in which we manipulate the formula and solve for the mass of the object when we know kinetic energy and velocity, and last but not least, in the third example, let's go ahead and figure out the velocity of an object when we know the object's mass and how much kinetic energy it has. So let's take a look at example number 1. In this first example, it says to calculate the kinetic energy of a 750 kilogram race car traveling 55 meters per second down the racetrack. So if we take a look, we have a race car, and this race car is going to be traveling down this track here at a velocity of, it says, 55 meters per second. Also, what we know about this race car is that its mass is equal to 750 kilograms. And so what we want to know about this race car is how much kinetic energy does this race car have if it's traveling down the track at 55 meters per second and has a mass of 750 kilograms. So we can easily figure this out using the kinetic energy formula. We know that kinetic energy of an object is equal to 1/2 the mass times the velocity squared. And when we're working with the kinetic energy formula, we can basically write this formula or expression like this right here. mv squared over 2 equals the kinetic energy. Okay, and so in this problem here, to get the kinetic energy, all we need to do is plug in these values here. When we're working with these values, we need to make sure that the mass is in kilograms, which it is. We need to make sure that the velocity is in meters per second, which it is, and we can go from there. So the mass of this object is going to be 750 kilograms, 750 kilograms, and its velocity is 55 meters per second. And what we're going to end up doing is we are going to end up squaring this, and then we're going to end up dividing this whole thing by 2. And so when we put this in our calculator, what we will end up with is 1,134,375 watt. Well, let's take a look. We have kilograms times meters squared per second squared. And so anytime we have this unit right here, this unit right here becomes joules. This is the same thing as a joule, or capital J. And if we want to, we can convert this to scientific notation, and we can put this in the correct number of sig figs, which appears to be 2 sig figs, and we'd end up with 1.1 times 10 to the 6th joules of energy. So that's going to be how much energy this little race car has as it's traveling down this straightaway at 55 meters per second, provided that it has a mass of 750 kilograms. All right, so that's how we're going to find the kinetic energy when we know the mass and velocity. In example 2, let's figure out how we're going to figure out or calculate the mass when we know the velocity and the amount of kinetic energy. In this second example, it says a bowling ball is rolling down a ramp at a constant velocity of 2.5 meters per second and has a kinetic energy equal to 18.8 joules. What is the mass of the bowling ball? So, if we take a look down here, we have a bowling ball, and what we know about this bowling ball is that it's traveling down this ramp at a velocity of 2.5 meters per second. And we also know that this bowling ball has kinetic energy that is equal to 18.8 joules of energy. And so what we're trying to figure out here is the mass of this bowling ball. We want to know, based on the velocity and kinetic energy it has, what is the mass in kilograms of this bowling ball. So we know that kinetic energy is going to be equal to mass times velocity squared over 2. And in this problem here, what we're trying to do is we're trying to solve for the mass of the bowling ball. So we have to get mass, or m, all by itself on one side of the equal sign. And so we have to use some algebra here. We're going to multiply both sides by 2. If we do that, this cancels. And so now we have 2 times the kinetic energy is going to equal the mass times the velocity squared. And so now, how do we get m all by itself? We're going to have to divide both sides by v squared. V squared now cancels over here. And so to get the mass of this bowling ball, we take 2 times the kinetic energy, and then we're going to divide by the velocity squared. So let's go ahead and plug these numbers in and make sure that the kinetic energy is in joules first, which it is. Let's make sure the velocity is in meters per second, which it is. So we can just start plugging numbers in. So to get the mass, we're going to take 2 times the kinetic energy, which is 18.8 joules. And we're going to divide this by the velocity, which is 2.5 meters per second. But we're going to end up squaring this. And so when we put this in our calculator, we're going to end up with 6.0. If we use the correct number of sig figs here, we have to use 2 sig figs. We have 2 sig figs here and 3 here. Our answer must contain 2. And then we're going to end up with this unit of measurement right here. We're going to end up with joules over meters squared times seconds squared, right? And so anytime you have this unit of measurement right here, joules over meters squared times seconds squared, you're going to end up with kilograms. This right here just gets converted into kilograms, and so we have 6.0 kilograms. So the mass of this bowling ball, provided it's traveling down this ramp at 2.5 meters per second and has kinetic energy equal to 18.8 joules, is going to be 6.0 kilograms. Let's take a look at another example. In this third and final example, it says a locomotive has a mass of 190,000 kilograms and has 2.5 million joules of kinetic energy. We want to calculate the velocity of this locomotive. So we have a locomotive, it's traveling this way. And what we know about this locomotive is that its mass is equal to 190,000 kilograms. So pretty massive. And that we also know that it has 2.5 million joules of kinetic energy. So this thing here has a kinetic energy equal to 2,500,000 joules. And so what we're asked to figure out is, if its mass is this and its kinetic energy is this, we want to figure out how fast is this traveling. How fast in meters per second is this locomotive traveling down the tracks here? So we know that the kinetic energy of an object is going to be equal to the mass times velocity squared over 2. And in this problem here, we're asked to solve for v. So we want to get v all by itself on one side of the equal sign. So we're going to multiply by 2 here. And what we do to one side of the equal sign, we must do to the other. 2 is going to cancel out here. And so now we are going to end up with mv squared equals 2 times the kinetic energy. But now we want to cancel out m, or we want to get rid of m from the left-hand side of this equation. So we divide by m here. We're going to divide by m here. And so now we end up with v squared. We'll put this over here. We're going to end up with v squared equaling 2 times the kinetic energy divided by the mass. But we're not solving for v squared here. We're trying to solve for just v. So what do we have to do here? We now have to take the square root of both sides. If we take the square root of both sides, then v is going to equal the square root of 2 times the kinetic energy divided by the mass. So this here is our formula that we're going to use to solve this problem right here. So we're halfway done. So let's go ahead and plug these numbers in. We'll do this right up here. We're running out of room here. So the velocity of this train is going to equal the square root of 2 times the kinetic energy, which is 2.5 million, or 2,500,000 joules, divided by the mass, which is 190,000 kilograms. So we put this into our calculator, and we will end up with 5.1 meters per second. Okay, so whenever you have the unit that you see right here, joules over kilograms, that gets converted into that can be converted into meters per second. Okay, so the velocity of this train is going to be 5.1 meters per second. If you like what you see, go ahead and click the little bomb in the bottom right hand corner, and that's going to subscribe you to my channel. And feel free to leave any comments in the comments section down below, and I really hope you guys found this helpful.